Good morning.
Hello, everybody. Thank you for being there, even if you're angry now. I'm Sandrine Bethmont. I'm from SETEC. I'm a concrete specialist and also a business developer for renewables energy for SETEC. And Aldéric, my colleague, is from SAFIER INGENIERIE. He's an offshore structural engineer and also business developer for renewable. We are here today to discuss about the worldwide plans to install hundreds of gigawatts of offshore wind power, including a large part of floating one, of course. Only in the European context, as the minister told this morning, that means the installation of more than 7,000 of floating offshore wind turbines, and they have to be produced, maintained, manufactured, and installed, etc. All the supply chain. So, is this supply chain ready to answer to these needs, the huge needs of this serial production? Do we have the infrastructures, the port facilities able to achieve all these projects in such a short delay, because it's before 2050? Maybe not yet, but we have solution. We have to work on this solution, and we will present today one of these solutions. Okay, ça marche. Thank you. This is a solution we called MOP-ALFOWT for modular offshore platform. It's a floating offshore platform. Okay, it's just a picture to illustrate our concept, and it's a concept enabling assembly line for a floating offshore wind turbine. It's code compliant with international standards for concrete and offshore structure. We will explain that after. It is based on the floating island concept. It's sized, fitted, and optimized for the serial fabrication of floats. You can see there that assembly, or the assembly chain, loadout, storage of components, and weight storage can be installed on this platform. It's not a concurrent, a competitor of port infrastructure. It could be also an extension of port. Okay, vas-y. Alors, maybe if you can click, thank you very much. This solution creates a complementary floating area, as I said. It's several hectares, because here it's an illustration of one of the layouts we can design. It's a 400 meters long by 100 meters wide platform there. And as you can see, it's a bit fast, but you have seen that there are floating concrete caissons constituting this platform. They are assembled by a special connection that Aldéric will explain after. And it's clearly an advantage with respect to a fixed platform or bottom, well, let's say supported by the seabed, and because it has less impact on our environment, and also this platform can be towed between several port areas, let's say. It can be shared between ports, for example. This configuration here is presented for steel floaters, but thanks to the modularity of the platform, it can also be adapted to other type of floaters. Let's imagine concrete floaters with another layout, of course. It can also be adapted to the different sites, port sites, and different country. Okay, let's say it's very modular. I will let Aldéric explain you a little bit.
Thank you, Sandrine. I will explain you now what makes our concept unique, economical, safe, reliable, and also competitive to compared to traditional port facilities. So the grit of our solution stands on two keys technology. First one is a singular caisson design. And the second one is an innovative matching process between the two caissons. So let's speak first of the first part, the first key technology, our single floating caisson design. All our platform is made of assembled caisson. All the caissons are one single same design, which is here the case of a 80-meter long by 20-meter wide caissons. Each caisson is fitted with 4 specific extremities at each of its sides, and which allow the caisson to be connected to up to 4 caissons on each of its sides. The second key technology is our innovative matching process. It comes from SAFIER engineering company, our company that has patented this connection called C2C. It has been developed in the last 8 years. Among other projects, has been developed particularly through an European granted project called the Blue Growth Farm. The patent is based basically on a mix between the submerged tunnel technology and the concrete bridge technology. We have adapted the two technologies of fabrication to floating structures, to floating operation. The brightness behind this process is that the C2C allows connecting a float, 2 caissons together in a water depth about 10 meters. Also, the connection fully rebuilds the cross-section of the single caisson. Therefore, once assembled, it results in an assembled hull that is entirely, totally monolithic, as one floating superstructure that has been built on sea without any needs of dry docks. Therefore, both our single caisson shape design plus our matching process lead to a high versatility of floating platform in terms of shape, size, and payload capacity. The SETEC SAFIER solution that we are presenting to you emerged from our extensive technical experience in engineering of floating structure and our extensive engineering experience in very large concrete structure that we share between the both companies, SETEC and SAFIER. By one side, SETEC has got a large track record in design, fabrication, and installation of very large concrete structure, coming from many years of landmark projects like the Channel Tunnel or other main worldwide bridges, as well as even more specific expertise in floating structure, floating concrete structure, like the project of the Encosa oil platform, production platform, or the floating dike of Monaco. And by the other side, we got SAFIER engineering, where we got a large track record in design, fabrication, installation of offshore structures, coming from more than 40 years of structural engineering, structural engineering in the oil and gas sector and in the renewable energy sector worldwide. As a result of the union of these two expertises, SETEC and SAFIER are coming up with this concept of modular offshore platform. You can see here some pictures of the studies ongoing. We kicked off our collaboration last winter by engaging on the technological qualification process for new technology of DNV. With the first milestone will be this summer with the obtention of the statement of feasibility. In parallel to the technology qualification process, we also performed a conceptual engineering development, raising the technology up to date to Taylor 3 for sheltered sea environment conditions. Our feed engineering study is confirming both aspects, the feasibility of the matching process C2C and the structural integrity of the assembled hull.
So feasibility is demonstrated. It starts to be demonstrated. And however, the need for port development and conversion is a reality. It's now. It's really a current challenge for the offshore wind industry. And we have to go further of this feasibility. We won't talk about money today, but however, the investment required are very substantial to develop all these projects, offshore projects. We have seen in Scotland, for example, that the necessary investment for port developments are around 4 billion pounds. It's huge. So we can imagine now optimization of this supply chain. We can imagine, sharing between infrastructures, and that's why we propose this solution. We need our facilities need to be modular. We think it's really an important need to be modular, shared maybe. It can be temporary infrastructure because it's floating, and especially it's flexible. We think it's time to act. We can participate to this transition with our modular offshore platform, and we started to initiate our studies few months ago, but the collaboration is older. But this study started months ago, and we presented already this concept to different partners, different investors in Europe, and they are quite motivated to follow us. We go most forward now, and because it's also a global and worldwide matter to solve. Here is the roadmap of our studies. Aldéric told about the feasibility study. We are here in the TRL 3. TRL is a technological readiness level. Thank you. So it's the feasibility, and we are working with DNV for having the statement of feasibility at the end of July of this year. So it's tomorrow. As you can see, the timing is ambitious, and it's matched with the schedule of the different coming European projects for offshore wind developments. But we have to work now. In the next years, we will finish the feasibility after develop the technology validation by performing basin test, prototype testing, up to the third-party product certification. And the assembly of the first platform is expected to be performed at early 2030. To achieve these nice studies, we wanted to thank our teams now. We have mobilized the two teams, SETEC and SAFIER people, to reach all the project's targets. And as explained by Aldéric, we have complementary skills. Meanwhile, remaining independent engineering companies. SETEC is a multidisciplinary engineering specialized in civil engineering, and we work on steel or concrete structures. SAFIER is a cross-energy engineering with expertise in offshore structure especially. And as I said, we started our collaboration a long time ago, almost 30 years ago, by working together on the National Beijing Opera. It's a very nice structures. We are now motivated to continue this adventure. It's passionate. We need you to follow, to pursue these studies. We need investors, we need partners, and come with us to reach the next steps.
Thank you, Sandrine. Conclusion, ladies and gentlemen. Thank you for staying at this lunchtime hour. we hope that through this presentation of our innovative concept of modular offshore platform, we gave you appetite to learn more about the technology. We hope that we can satisfy this appetite by during these 2 days. If you visit us on our stand, so G40, just around the corner, just behind. Or later, you can take contact of Sandrine and myself to discuss this concept more in detail. Our modular offshore platform MOP, as you could understand, is an innovative solution responding to the need of the ports of tomorrow for the wind farm supply chain. But it's also a solution that can be tailored to many usage on sea as a floating extension of land of any kind, as an answer to the rise of the seawater level and the lack of space on Earth. Our innovative solution process between the two caissons will be successful in the serial fabrication of any floating large structure. One of the utilization of this patent is also something we are developing with SETEC. It's adapting the C2C connection between the caissons as to an economic and safe solution for the serial fabrication of floaters of the wind turbines of tomorrow, the 10-15 megawatt of tomorrow. So we'll be more than happy to comment this on our stand if you come about these several possibilities and adaptation of our technology. Thank you very much.
Yeah.